Okay, guys, how are you all? Hope you are all doing good. Today, this lesson, we'll continue our lessons from chapter 6, section 2, where we're going to talk about covalent bond. Before we start mainly at our section, I just want you to remember that we talked about how to find out the type or the nature of the bond. And that actually depends on the electronegativity difference. So we said we have 0.3 and 1.7. We said before, if the difference between atoms, between electronegativity of two atoms, is less than 0.3, that means that we have non-polar covalent bond. And if the difference was between 0.3 and 1.7, that means that we have a polar covalent bond. And if the difference is over 1.7, that means that we have here ionic bond. So, as the difference between two atoms is less than 1.7, that means that we will have a covalent bond. Why we are talking about covalent bond? Because actually the compounds where atoms are connected to each other with a covalent bond are called molecular compounds. So, covalent bonding and molecular compounds, we're going to talk here about molecules, molecular compound, chemical formula, and molecular formula. As a start, what do you mean by molecule? Okay, now if you have a wall, the wall will be made of many bricks together. And all those bricks will form the wall. Now if we took the wall here, we will have a compound, while the one brick will be called a molecule. So the molecule is the smallest unit of a molecular compound. Focus, molecular compound. We called it molecular compound because actually it's made of molecules. Okay, so a molecule is the neutral group of atoms that are held together by a covalent bond. Okay, so when we have two atoms connected to each other with a covalent bond, that means that here we have what we call a molecule. And many molecules together, they will form what? Yes, molecular compound. Okay, so a chemical compound whose simplest unit are molecules is called a molecular compound. Now, we have two new terms, chemical formula and molecular formula. What is the difference between chemical and molecular formula? As you can see here, the chemical formula indicates the relative numbers of atoms of each kind in a chemical compound by using aromatic symbols and numerical subscript, while a molecular formula shows the types and the numbers of atoms combined in a single molecule of a molecular compound. So the chemical formula of a molecular compound is referred to as a molecular formula, which means that if we are talking about, now to understand it, let's talk about, for example, in A, Cl, and H2O. Now NaCl, as you know, is made of Na plus and Cl minus, which are ions. So here we have ionic compound. So we can say that NaCl is a molecular formula for sodium chloride, because here we have no molecules. So how come that we can say molecular? So the word molecular refers only if we have a molecules like H2O. So here, because we have molecule, so we can say that when these molecules are together, and for example a vessel or a cup or whatever, we can have a molecular compound. So for ionic compound, we can't say molecular formula. We have to say chemical formula. We are talking about a chemical compound. We are not talking about a molecular compound. So chemical formula or chemical compound is something general. We can talk about anything as a chemical compound. But when we say chemical or when we say molecular compound, that means that the bonds between atoms in this compound is made of sharing of electron, which is covalent bond. No ionic bond, no metallic bond, nothing. It's just covalent bond. So covalent bonds between atoms will give us a molecule. Many molecules together will give us molecular compound. How can we represent or write or specify this molecular compound? By using a chemical formula. Okay, this is in general. So for example, we can say H2O, which is water, or oxygen molecule, or sucrose molecules C12, H22, O11. All of them here are bonding to each other with a covalent bond. So here we have a molecular compound because it's made of molecules. And because of the atoms between molecules, the atoms are held together with a covalent bond. Okay, guys? So this is the meaning of molecular compound. Now in this shape here, I just wanted to only follow the change of potential energy between atoms in a molecule of hydrogen, H2. Now at point A here, as you can see, where there is no any connection between two atoms, nothing between them, the potential energy is 0. So separated hydrogen atoms do not actually affect each other. While in B, here, in B, potential energy decreases because the atoms are getting closer to each other and they are somehow drawn together by attractive forces. While in C, as you can see, the potential energy is at a minimum quantity because here the attraction forces are balanced by repulsion force in hydrogen molecule. Now, if the bonds getting closer to each other, okay, the potential energy will increases because the repulsion forces between two similar charges, as you can see here. We have repulsion forces in blue arrows between electrons together, because as you see, the electrons are negatively charged. So when the electrons are closer to each other, they will cause repulsion forces between each other. And at the same time, the nucleus of each atom is positively charged, which is the main part of the atom. So they will repel each other and taking the atoms further from each other. Now, when we have balancing between these repulsion forces and the attraction forces, we will have the lowest or the minimum potential energy between atoms. Now, the repulsion will be a result, the attraction forces, it will be a result of attraction between the nucleus of the first atom with the electrons of the second atom, as you can see in the red arrows. So each nucleus in each atom will attract the electrons of the other atom. And this is the main reason for attraction forces between atoms. Okay? we said before, in ionic bond, the electrons will move completely from the orbitals of the atom that losing the electrons to the orbital of the atom that gaining electrons. While in the covalent bond, we said that it is a type of or a kind of sharing of electrons. For example, H plus O. As you know, hydrogen contains only one valence electrons, while oxygen contains 6 valence electrons. Now what will actually happen here is that hydrogen will share the electron atom with oxygen. So a new orbital will form as a result of sharing of electrons between two atoms. And the electrons will behave as if they belong to the both atoms at the same time. So the electrons will behave as if they belong to hydrogen and at the same time as if they belong to oxygen. So they are still related to both atoms at the same time. This is the meaning of sharing. And this sharing actually, it will be as a result of overlapping between atoms. Now, remember that hydrogen electron configuration is 1s1. So we have s orbital of hydrogen where the electron could be. While the orbital of oxygen here, it will be like a type of dumbbell. Now the sharing result between both of these orbitals will be this way, or this will be S and P orbital. To understand the overlapping more, as you can see here, H plus H will give us H2. Look at the shape of the orbitals between two hydrogen atoms. It was spherical orbital because it was S orbital with S orbital. Now look at the new orbital of hydrogen. Look at the point P where we have sharing between S orbital and P orbital between hydrogen and F. Now look at the shape of the shared or overlapped orbital between F and hydrogen, and look at the size at the same time. While if you look at the third example like C, you can see the overlapping between P and P orbital, and I'll show it for you to understand more. Here, if we have, this is P orbital will overlap P orbital, it will form like now this is the electron cloud of the electrons, and the electron could be anywhere inside these orbitals. So this one is P plus P orbitals. Okay guys, now I hope that you get all the point here. I just want you to focus on the main point. We talked about molecule, which is the neutral atom of atom or group of atoms that are held together by covalent bond. Many molecules or molecules together will form a molecular compound. The molecular compound can be represented by a molecular formula, or can we say chemical formula? But the molecular formula is for molecular compounds only. We can't say molecular formula for ionic compound because we have no molecules. Okay, and as we said, covalent bond is a sharing of electrons. There are no losing, no gaining of electrons. We have only sharing of electrons between atoms together. Okay, it will be a result of attraction between nucleus and the electrons. As we said, for example, this is oxygen atom molecule, and this is hydrogen. We have electron here and we have electron here. So what actually happened is that the nucleus will attract the electrons here, and the other nucleus of hydrogen will attract the electrons of oxygen atom to form OH bond. And because of the electronegativity of oxygen is higher than hydrogen, as you remember we said that the electrons could be just closer to oxygen, but it will still act as if it only belonged to hydrogen, but it will somehow being closer to oxygen because the difference of electronegativity. This is why it will take partial negative and hydrogen will take partial positive. While in ionic bond, as we said, we will have totally negative and positive. We don't have a partial charges distributed for atom. This is something else we're going to talk about it later, inshallah. Take care and see you in the next lesson.